Notes 2A. Domain and range of linear functions. Your objective is, how can I identify domain and range? Your essential questions are, how can I find domain and how can I find range? When you're taking these notes, I expect you to join the Pear Deck and contribute to the slides. Watch this video, fill out your foldable, and ask questions whenever needed. On the Pear Deck slide, answer this question. Drag the icons on what kind of pet you own. For example, if you own a horse, drag one of the icons over horse. If you have something else, drag it over here. If you don't have any pets, drag your icons over here. Become familiar with this vocabulary. Continuous is measured. Discrete is counted. Domain, left, right, x. The independent x value reads from least to greatest. Range, down, up, y. The dependent y values are read from least to greatest. We have less than, greater than. Those are open intervals. And we have less than equal to, greater than equal to. Those are closed intervals. Continue versus discrete. I'll do this example for you. Population. That is something that is counted as a discrete variable. Price of items on a menu is also discrete. Even though 59 cents is a decimal, this would still be considered discrete because you could count those items on the menu. Width of a box. This would be considered continuous. And mass of gummy worms, that would also be continuous. Here's an example of a discrete map. And here are some continuous ones. This one right here is a piecewise function. It's mostly continuous, but some of it's discrete. So it's discontinuous here. And it's discrete here. And then the rest is continuous. On the next slide, you do this one. Drag the icon. Do you think time is continuous or discrete? Why did you choose that answer? Domain given a graph. I'll do this one. Domain is left, right, x. So the left number is 1. The right number is 4. And then x goes in the middle. We have less than and then less than equal to. This one's an open hole. This was a closed point. Closed point. Is this increasing? Yes. Is this decreasing? No. Okay, the domain for this one is discrete, so it's going to be a list of numbers. So let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, now you do the next slide. Determine the domain of this. Let's just say this is 1, this is -1, 1, -1. We'll say each square represents one increment of length. So on your slide, you want to draw D equals and then set. You will identify the 4 numbers. Domain given a set. I'll do this one. So we have f of x equals negative x plus 10. Our range is 0, 4, and 9. To do this, to find those values in the domain, we want to set this equation equal to 0, 4, and 9 and solve for those domain values. So when it's 0 equals negative x plus 10, we're going to subtract 10 and divide by negative 1. So x would equal 10 here. So 10 would be one of the numbers. We do want to have the numbers in order from least to greatest when we write our set. So let's order them at the end. Okay, now let's set it equal to 4. Subtract 10. Divide by negative 1. So we have x equals 6. And then we're going to set it equal to 9. 9 equals negative x plus 10. Subtract 10. Negative 1 equals negative x. Divide by negative 1. X equals 1. So order from least to greatest would be 1, 6, and 10. So you try it now. You're given the range of negative 2 and 7. You want to find the two domain numbers. To do that, you want to solve both of these equations and order them from least to greatest. So the steps are you want to add and then divide. Go ahead and do that. On your slide, write out your answers. Domain given a word problem. I'll do this first one. The student council sent its members on 4 field trips during the school year. The number of buses needed to transport the members on each field trip is a function of the number of members who went on each trip. This function consists of only the ordered pairs 52, 3, 72, 4, 86, 5, and 105, 6. What is the domain for this situation? Remember, domain is left, right, x. And so we're only going to look at the x values. Those are the x values right here. So we're going to order those from least to greatest. Looks like they're already in that order. So we have 52, 72, 86, and 105. And that's our domain. On the next slide, go ahead and do this domain given a word problem. The student council sent its members on 4 field trips during the school year. The number of buses needed to transport the members on each trip is a function of the number of members who went on each trip. This function consists of only the ordered pairs 36, 2, 54, 3, 64, 4, 85, and 108, 6. What is the domain for the situation? Choose the option that is the correct answer. Type one thing you know about domain on this side, and type one thing you know about range on the other side. Range given a graph. I'll do this one. The range of this linear graph right here is all real numbers. You could write that like this. You could write it with words. And then an informal way of writing this could be as an inequality. When you're given answer choices, you'll most likely have the words spelled out for Algebra 1. Okay, now let's have one that's a restricted domain here to find this range. So the range is down, up, y. So we're going to find the lowest y and draw a horizontal line through it. And we're going to find the highest y and draw a horizontal line through it. Not the highest y on the graph, but the highest y of the picture that is graphed here. So the smallest number is negative 2. The largest number is positive 2. The lowest number is a whole, so it's open whole. So that's a less than symbol. This one right here is a closed point. So that means we have less than equal to. And of course, range is y, so we're going to put y in the middle. They might also put f of x instead, so be careful with that. Okay, now go to the next slide and try this one on your own. Given this range, what is the range of this graph? Choose an option. Range given a set. I'll do this one. So you're given f of x equals negative 2x plus 1, where the domain is negative 5, negative 1, 0, and 8. To find the range of this, we're going to evaluate. When you were finding the domain, you had to solve. For this one, you only have to evaluate. So we have negative 2 times negative 5 plus 1. To evaluate this one, we could put it in our calculator, or we could just evaluate by hand. So we have 10 plus 1. That's 11. Let's plug in the next one. Negative 2 times negative 1. That's going to give you 2 plus 1. That's 3. Notice each time the only thing we're changing is the x value. So parentheses, whatever number that's in the domain for that one. This was 1, and then the last one, that's going to give you negative 16 plus 1. That's negative 15. Order these from least to greatest, and we get negative 15, 1, 3, 11. On the next slide, you try that one. You're given f of x equals 5x plus 8. Your domain is negative 2, negative 1, 0. And I erased the other one, so you only have to do 3. Evaluate these 3 elements to find the range. Do it for negative 2, negative 1, and 0. Range given a word problem. I'll do this one. The student council sent its members on 4 field trips during the school year. The number of buses needed to transport the members on each trip is a function of the number of members who went on each trip. This function consists of only the ordered pairs 52-3, 72-4, 86-5, and 105-6. What is the range for this situation? So let's recall that range is down, up, y. So we're only looking at the y values. That's the second number. So we're going to order these from least to greatest. They look like they're already in the correct order. And that would be our answer. On the next slide, go ahead and answer the word problem on here for yours. Choose the option that is the correct answer. So, there's inequality notation and there's interval notation. In Algebra 1 multiple choices, they'll usually give you inequality notation. In Algebra 2, they'll usually give you interval notation. They mean the same thing, they're just different ways of writing it. So here's some examples. We have x is greater than 5. That's open, so we have an open hole, and it keeps going forever to the right because it's bigger than 5. So we have parentheses 5, comma, infinity. If we have a line underneath our inequality symbol, that's when we have a closed point. Closed points will have a bracket for the interval. There's also compound inequalities where we have and x is in between 2 numbers. And we have one interval, one inequality. And then we have OR compound inequalities, where we have the middle part is not shaded in and the outer parts are. So we have two inequalities, two pieces of the line graphed, and two intervals. This U right here in between the two intervals is just for union, which means OR. Of course, if you have all real numbers, everything is graphed. X is an element of the real numbers, and your interval is parentheses negative infinity to positive infinity. They'll never write it in inequality notation for all real numbers. Remember, X is domain. It's read left to right. Left, right, X. Y is the range. It's read down to up. Down, up, Y. Arrows are representing either negative infinity or positive infinity depending on what direction it's pointing. Parentheses tells us that the interval is open. You also could have inequality symbols without lines on them. Dashed lines, holes, and arrows are all open things. Brackets tell us that the interval is closed. We also can have less than equal to, greater than equal to, solid lines, points, and vertices. And sets have braces. Those are for discrete values for the most part. So how do you feel about today's topic? Drag the icon on how you feel about today's topic. Can you explain it to someone? Do you know it? Is it getting more familiar, or are you not quite sure yet? On the last page of your Pear Deck, write your summary. Write the difference between domain and range. Be sure to use complete sentences. While you write your summary, use these words in this word bank. Once you're done with this, go to the next activity.